Over 2 billion tons of waste are produced by humans every single year, and glass makes up nearly 20% of that massive pile of garbage. The crazy part is that a single glass bottle can sit in a landfill for 1 million years. It sits there without ever breaking down or decomposing naturally. But here is the good news: glass can actually be recycled forever. It can be recycled infinitely without ever losing its original quality. So how does this incredible recycling process actually work in real life? How do messy broken shards get reborn into clean, shiny new bottles? Let us step inside one of the world's largest glass recycling factories, where hundreds of tons of glass are brought back to life every single day, and uncover the secrets behind the unbelievable journey of this sustainable material. Let us get started with the very first step of the process. To recycle glass, the first requirement is steady supply of used bottles in daily life. Empty beer or soda bottles are often tossed with regular trash. This makes sorting for recycling costly, complicated, and highly inefficient. But in many European countries, a system handles this problem at the source: glass bottle return. Machines are installed across city streets and supermarkets. Consumers simply place an empty bottle into the automated machine. The machine scans the bottle, sorts it, and prepares a refund. It gives back a small refund, usually around 10 to 20 cents per bottle. That means a freshly finished beer bottle instantly turns into a valuable asset. Instead of ending up as waste, it has immediately cash value. This clever approach motivates people to collect and return bottles on their own, while also providing factories with a stream of pre-sorted clean glass. Europe seems to have this collection process completely figured out. But what about the United States? Do we have systems this advanced here too? Drop a comment below and let me know what you think about this when the reverse vending machines and public bins are completely full collection. Companies send out specialized trucks to pick up the sorted bottles. Large plastic bins, each holding thousands of empty glass bottles. These massive bins are loaded onto the trucks with heavy forklifts. A single full-size truck can carry between 20,000 and 30 ESO bottles. This is equal to about 10 to 12 tons of raw glass material. Trucks loaded with glass bottles quickly make their way to the recycling plant. Each truck carries tens of thousands of empties packed tightly in bins. When they arrive, the drivers back up to a massive storage bay. They release the load, sending a cascade of bottles tumbling down. In just minutes, the ground fills with colorful mountains of glass. These bottles sparkle beautifully under the bright daylight. Greens, browns, and clears stack together in giant colorful heaps. These piles are not just waste. They are the starting point. They are the beginning of the entire glass recycling chain. A steady supply of raw material waiting to be cleaned and crushed to kick off the recycling process. Massive loaders drive up the piles. They approach the towering piles of waste glass with determination. They scoop up huge loads of bottles with their giant buckets and carry them swiftly across the busy factory yard. With a thunderous crash, the glass is Finally dumped, it goes directly into the plant's massive feed hopper. Sending a cascade of shards down the steel chute, carrying the stream of glass. Mixed with dirt and sand, it travels deep into the heart of the recycling facility. The very first stop is the vibrating screen machine, where powerful shakes separate out dust, grit, and tiny particles. After this stage, the glass is much cleaner, but larger contaminants that machines cannot detect still. Remain along the conveyor belt. Human workers stand ready, carefully pulling out paper, plastics, and unwanted items. This blend of mechanical screening and human hands works wonders. It produces a much cleaner batch of raw material ready for the next step in this recycling journey. Do you know what is still hiding in that pile? The bottle caps. Luckily, most are made of metal, which means they can be pulled out easily with magnets. The principle behind this magnetic separation is very simple. The strong magnetic field grabs the bits of steel, while the clean glass keeps moving down the conveyor. Thanks to this step, the glass is now about 8% clean and one step closer to its journey of rebirth. Once most of the contaminants have been successfully removed, the glass moves on to the next crucial step, being ground into what the industry calls cullet. The larger pieces are fed into a hammer mill, a massive machine with high-speed rotating hammers that smash the glass over and over again until only tiny, uniform fragments remain. Any pieces that are still too big are automatically detected and sent back through the mill until they are right. This makes sure the entire glass stream is uniform, with no stragglers or oversized pieces slipping through the process. Creates beautiful sparkling cullet, fine, sparkling glass particles that look like man-made sand, because it is broken down so small. Cullet melts faster, saving up to 40% of the energy required compared to using raw materials like sand or limestone. After that, the cullet is carried to a suction system where it is blasted with a strong stream of air. This airflow strips away and blows off leftover labels, leaving the glass cullet even cleaner than before. Finally, the cullet moves into the optical sorting system, the most precise step in entire recycling process. As the glass cascades down like a shimmering waterfall, laser sensors continuously scan each tiny fragment to detect its exact color and chemical composition. The moment brown glass, green glass, or ceramic is identified, the system instantly fires. A precise puff of air shooting the targeted shard into a separate stream. The speed of this optical sorting is almost unbelievable. Tens of thousands of pieces are processed every single minute. This ensures that the cullet is sorted with perfect accuracy, because even a slight mix of the wrong shade ruins quality. Once the cullet has been sorted, it continues moving. The tiny glass particles are directed into separate storage areas. Each storage area is strictly divided by glass color. There they gradually pile up into massive stockpiles, waiting to be transformed into brand new glass bottles after. Being sorted and ground down, the cullet is ready. But it cannot go straight into the furnace alone. It needs to be blended with raw ingredients first. The mix starts with pure silica sand for clarity. Then comes soda ash to lower the melting temperature, and limestone is added to make the glass stable.